Welcome to a video on functions and graphs. This one's looking at function notation, and it's just a revision video, nice and short. We're just having a look at a couple of key examples each time. Okay, this question says given f of x equals 2x plus 5, it wants us to find f of 2 and f of minus 3. So what happens in these ones, it's a funny sort of way of saying things, but if x operates according to this rule here, 2 lots of x plus 5, then anything in the brackets can take the place of what the x is doing. So when you've got f of 2, wherever you see an x in the original expression, we're going to replace it with a 2 and then calculate from there. So f of 2 is going to equal 2 lots of 2 plus 5 instead of 2 lots of x plus 5. And so we can calculate that one out to be 9. So we really just replace the x with a 2. Okay, so for the second bit, f of the function of minus 3, that's the new function value of minus 3 instead of an x. So we'll put the minus 3 wherever there's an x in the function there, and it goes just after the 2. So 2 lots of minus 3 would be minus 6, plus the 5 from the original expression, and we'd get minus 1 for our answer there. So it's kind of a strange way of expressing it, called function notation here, but it just leads us to replace the x in the function with whatever function value is in the brackets each time they ask us to process. Okay, so here f of x this time, we're not given a different value to sub in, but we're given the result of the whole thing. So we can just piece that together here. If we replace the whole of f of x, so you've got f of x equaling 25 there, and f of x equaling this expression of 4x minus 7. So we can replace the whole f of x section there with a 25 and just get a normal equation out of that. So if the 25 goes where the f of x is, and we've got that 4x minus 7 on the other side, we'll just solve that as a two-step equation. We'll add 7 both sides and divide by 4 both sides, getting x equals 8 in the end. So yeah, we didn't replace the x there, we replaced the whole f of x section when they told us f of x equaled 25. Okay, here this is a triple banger here. It's got 3 rules in one, and we're going to figure out there's different rules for different values of x here. So one of the things we have to do is we say, okay, if we're going to process a function value of minus 1, we've got to have a look over here and see what category that is in, and when it's in a certain category it follows the rule that's beside it there for that function value. So let's have a look. F of x, so x is minus 1 here, so x being minus 1 would have to be in this category here. So it's following this rule here with an x value of minus 1. So we'll put a minus 1 wherever there's an x in this rule up here of x squared plus 4x. So instead of x squared plus 4x, we've got minus 1 squared plus 4 lots of minus 1. So see how the minus 1 has replaced the x in this rule up here. We decided on that rule on the top there because of the value of the x, minus 1, fits into this category, x is less than or equal to 1. So we're following that rule, we sub it in. Now minus 1 squared is 1, minus 1 times minus 1, minus times a minus makes a plus. 4 lots of minus 4 is, 4 lots of minus 1 is minus 4. So we get a 1 for the top bit, plus a minus 4. So that ends up being minus 3 for that section. Now, for f of 2, we have a look up here, and it's this category here that the x value of 2 fits in. See how this is true if x is less than or equal to 2, and x is equal to 2. So it's this rule here we're following for that value. So we're going to replace the x in this rule with the 2. So instead of x plus 7, we've got 2 plus 7, making 9 there. So we followed a different rule because it was a different x value. And this last one, this is quite a weird one, this one. The function value of 6, which fits into this category here, because x is greater than 2 for this category. And we don't have any spot to put the x. We don't have any place to replace x with here. So no matter what happens, when x is greater than 2, 5 is your result no matter what. So when we have a function value of 6, that turns into a 5. So then the final expression here they want is the result for f of minus 1. They want us to add it to the result we got for f of 2 and the result of f of 6. So we've got our three answers here, three parts of that expression. So we'll just write that all out. We've got minus 3 for our first answer here, 9 for our second answer, and 5 for our third answer. And the question just wants us to add those all together, leaving us with 11 altogether. Minus 3 plus 9 is 6 plus 5 is 11. So kind of strange question. It's like a different rule depending on which function value we've got there. So you look for the category that the function value fits into on that right hand side, and then you follow that rule by substituting that function value into wherever the x is most of the time. So interesting, those ones. They're like three questions in one, really. Alright, there's a few relations and function. There's a few examples for you from function notation and how that works. So thanks for listening there. We'll see you next time.